First question is multiple choice. So select the best answer. Mark receives a score report detailing his performance on a statewide test. On the math section, Mark earned a raw score of 39, which placed him at the 68th percentile. This means that, so A, Mark did the same as or better than 39%. So we can automatically just cross these out. So cross A out, cross B out, because it's 68%, not 39. So we don't want to confuse the score and the percentile. We're talking about the percentile. We're talking about the percentage, not the score. So we can cross these out, okay? Now we're left with C, D, and E, okay? I can tell you right now, you can just cross out E, because in statistics, we want numerical answers, and that doesn't even have numerical answers. But for more valid reasoning, we don't know. Mark got more than half of the questions correct on this test. Okay, well, that would end up saying that he would be at the 50th percentile. Wait, but he is greater than 50th. Wait, okay. So why would E be wrong? Okay, because if 50th percentile is 50% and he is at 68%, that means he did get more. Oh, no. Oh, he's talking, no. He's saying this is in terms of the scores, the distribution, the data. The 68% is in terms of the students. So it would say, okay, well, 68% of the students got less than or equal to whatever the score is, which is 39, right? Less than or equal to 39, a raw score of 39. Okay, but got more than half of the questions correct on his test. So questions correct is where we go wrong. We're not talking about questions correct. This is not questions correct. It's talking about the raw score. So the variable that we're measuring is the raw score. The score is not the amount of questions that they got correct. So that's why E is wrong, okay? So look at me not editing this video and showing you my mistakes. Okay, so, all right. Then we're between C and D. So Mark did the same as or better than about 68% of those who took the test. Okay, now it's going to be C. Why? Because remember that when we're looking for a cumulative relative frequency, or the percentile, we are taking all the values that are less than and equal to up to that point. So in this case, 39. So this person took all the values that were less than and equal to 39, meaning that if he got a 39, that means that he did either better than, okay, or the same as those in that percentile, right? Because everybody got everybody up until that point is at the 68th percentile. So they either got less than a 39 or they got a 39, meaning that, what's his name? Mark got either a 39 or he did better because he has the maximum. So in comparison to the other students, he would either have he has a 39, so he did better or the same as. So we can say, because there could be a situation where, let's say the number of students, all of them got a 39, they would still all be in the 68th percentile. So that would have been like, they would all get the same, they did the same, right? They would do the same, right? Because they all got a 39. But I'm assuming that they didn't do the same and that there was like variation. So like, okay, one here, he got less than 39, but they were all in the 68th percentile, meaning that what's his name? Mark. I keep forgetting that Mark did better or the same as. So it depends, okay? So it would be C, right? Number 2, Mrs. Munson is concerned about how her daughter's height and weight compare with those of other girls of the same age. She uses an online calculator to determine that her daughter is at the 87th percentile for weight and the 67th percentile for height. Explain to Mrs. Munson what these values mean. Okay, so this means that the 87th percentile means that her daughter, does she have a name? No. Okay, her daughter weighs the same as or more than 87% of the girls her age. So her daughter weighs more than or the same as 87% of girls her age. And then likewise, she weighs actually 67, she actually weighs, she is taller or the same height as 67% of girls her age. So that's what that means, okay? Number 3, about what percent of calls lasted less than or equal to 30 minutes? Okay, so 30 minutes is right here. And we can see that this is a cumulative relative frequency. So we can just figure out what percent. So I'm going to say what? Let's do like 70%? So I'm going to say 70% of calls lasted less than or equal to 30 minutes, meaning which calls lasted more than 30 minutes would be 100 minus 70, which is 30%. So we could say more than 30 minutes would be 30%, about 30%, okay? About 30%. And then less than or equal to 30 minutes would be about 70% of the calls, less than or equal to 30 minutes, okay? Now, number 4, estimate Q1, Q3, and the IQR of the distribution of phone call length. Okay, so Q1 we already know is 25% of the data, so that's 25%. Q3 is 75%. So all we have to do is find it in the cumulative relative frequency line. Did I really just say line? Axes, excuse me. So 75% would be like right about here, kind of, not really, but we're gonna go with it. So that ends up being what, like 32? I'm gonna say 32. And then Q1 is 25%, that's about right here. And I'm gonna say that's 13. So Q1, 13, Q3, what was it, 32. So the IQR we know is Q3 minus Q1, okay? So Q3 minus Q1, that ends up being 32 minus 13, which is 19, okay? So that is our IQR of the distribution of phone call length, and that is how we solve these problems, okay?